Hey guys, welcome to my channel. I'm LeetCoder. If you guys are new to my channel, I pretty much do LeetCode style questions and I explain things in the simplest way possible. Today we have a pretty interesting problem, so let's get into the problem statement, right? So he says given in a binary tree, you need to compute the length of the diameter of the tree, right? It says the diameter of a binary tree is the length of the longest path between any two nodes in a tree, right? So this path may or may not pass through the root, right? So you guys can see we're given this binary tree. So this is a better example, right? So that's the tree that's given, right? So that's the same thing. So we got 1, 2, 3, all that, right? So the diameter of the tree, right, is the path, which is 4, 2, 1, 3, right? Which is the diameter is going to be 3, right? So the way that was obtained, right, is by getting, so the diameter happened to pass through the root, right? So we get the, so I did a problem similar to this, guys. It's going to call the maximum depth, right? So pretty much, we get the, so you guys should check that problem out. It's probably going to help you understand this problem better. So something's going to pop up on the screen. Then you guys could check it out. I'm saying, so this problem, right, is so at every node, right, we're gonna check our left maximum depth and our right maximum depth, right? Once we get the answer to those calls, right? So you see from the ones perspective, right, from the root node, we go left, right? We saw that the maximum depth from coming from this side is going to be 2, right? Because 1, 2, right? So 2 returns 2, since the depth of his maximum depth from this side, right, is 2. So returns 2, right? Because you got 1, 4 returned 1, 5 returned 1, and 1 plus 1 for 1 plus 1 to account for itself, right? It returns 2, 2, 1, right? So, all right, cool. The maximum depth from my left side is 2. So, what's my maximum depth from my right side? So then the right side does the same thing. Check left, check right, and returns 1 to the caller, right? You say, all right, man, my maximum depth is a 1, right? So it returns 1. So now 1, pretty much, once we had node 1, right? We add left and the right together, right? So 2 plus 1, right, is 3, right? So that diameter gets updated to 3, right? So that's the longest path so far, right? So we calculate the diameter every one of them, right? So at this particular point, the diameter was 0, right? 0 as well. And then once it was at that point, it was 1 plus 1. So that diameter at this point was 2, right? Because the path of the left side, the maximum depth of the left side, the maximum depth of the right side, right? 1 plus 1. And then 2. And then once you got here, right, it was 2. And then you do 2 plus 1 is 3. 3 greater than 2. So that's why the diameter then gets updated to 3, right? And yeah, so that case was a pretty easy case. The thing happened to pass through the root, right? Yeah, so there's another edge case. Yeah, guys, that's a very good edge case that we need to worry about. So this particular example, right, is pretty interesting. You can see that the diameter does not pass through the root, right? So yeah, because yeah, the diameter of the tree, right, the longest path, right, between any two nodes is this path, right? 19, 9, 2, 6, 5, 7, 8, 10, 20, right? That's the so the diameter of this binary tree is 8, right? Because of this path, right? It's not this one, what I'm saying. It's not that one because if we were to do that, the path would be less than this path, what I'm saying. So now the diameter of one, right, of that path would be 7 because of 1, 2, 3, 4, 5, 6, 7, right? Because 7 plus the maximum depth from the right side, right, plus 1. 6 plus 1 is 7. So it's less than this path, which is 4 plus 4, which is 8, right? The diameter is bigger for this particular path, guys. It's bigger. So that's why we need to, yeah. So as you guys can see, for at every node, right, we're going to compute the local diameter, right, for every node, right? And then we're going to compare it with the global diameter variable that's going to pretty much be that diameter for the whole tree, right? Right? Because we would get the maximum depth from the from 5's perspective, right? We get the maximum depth from the left side, the maximum depth from the right side, right? So it gets 4. The 4, right? How you get 4 is 1, 2, 3, 4, right? Because you know depth of 4, right? From this perspective, right? And then from 5 goes check the right again, right? The right then returns, checks its maximum depth as well, right? 7, 8, 10, 20. Again, guys, if you guys not understanding what I'm doing right now, you guys should really check out the other problem that I talked about. You know, I went into a lot of details talking about the maximum depth and how the recursive calls work, right? So yeah, guys, so once we get that, we get those answers from the subcalls, right? So now I got 4 from my left side, 4 from my right side, right? So now I add them up together, right, to get the diameter. So it will be 4 plus 4 is 8, right? So 8 is actually the diameter, right? So yeah, guys, so if we were to do this one, right, so 1, 2, 3, 4, 5, 6, right? So the maximum depth is 6, right, from the left side. And the maximum from the right side, right, is 1, right? So it would do 6 plus 1. So 1, 2, 3, 4, 5, 6. 6 plus 1 is 7, right? And then 8 is greater than 7. So 7, that would be wrong. What I'm saying, this is the longest path. What I'm saying, which is, you know, diameter of 8. So this is better, guys. What I'm saying. So the way we're gonna, yeah. So that's the, you'll see if you guys checked out the other video, it's gonna be the same code, guys, but we're gonna introduce the diameter variable that's gonna keep track of the maximum diameter that we've seen, right? So it's a very, very good, very, very similar to the other problem, guys. So yeah, so we're gonna have this like this instance variable, guys, called the diameter. All right, so once we're here, right? So we put that diameter equals 0, right? So now after we do that, right, we're gonna do we're gonna call this helper function. We're gonna call the helper function, right? We're gonna pass in the root, and after we explore, we do like DFS on the root, right? We're gonna return the diameter as the answer that we're looking for, right? Remember, we're gonna compute the diameter at every node, right? We're gonna check, you know, to see if that's a greater diameter than the previous diameter that we've seen before, right? So now it's a simple problem now. So we do helper. Might as well have called it maximum depth, right? So you just call it max depth, right? Max depth, right? Cool. So now tree node root. So now, guys, we check if a root is null, right? If a root is null, then we return 0. What I'm saying? Then the depth of a null node is 0, right? So now we recursively check our left. So recursively check our left and right child, right? So we try max depth, right? We pass in the left child to get, you know, then after we get the answer from the left, we go right. So after we go right, so we also need to, so once we get the answer from the left side and the right side, guys, you know, we're pretty much gonna be in pretty good shape. All right, so now we do the diameter. We go to map that max, right, of the current diameter that we have, right? The previous diameter, right? Initially it's gonna be 0, but it's gonna keep changing as we visit every node and all that, right? So, and then we do or right plus left, right? Add it together, right? And then after we do that, guys, you know, we simply return. So now we just compute the local diameter that we have, right? And we compare it with the global like diameter that we have. What I'm saying, the local diameter that we have is right plus left, right? That's our local diameter, guys. And the diameter variable that we have here, the global, is for the whole tree. what I'm saying? So now, once we know that, right, we simply, now we return our maximum depth, right? Because remember, we were, for every path, we need to return the, the depth, right? Remember, because every path is returning its maximum. So 4 returns maximum depth to 2, right? 5 returns its maximum depth to 2 as well. And then 2 returns its maximum depth to 1, right? So that's why we're doing that. We need to continue the path, right? And that's how we're creating the path, by doing that. You know what I'm saying? So now we do the left, so maximum out of the left or the right plus 1, right? So you guys see that all the videos are very similar, guys. Very similar. So I think we got everything correct. So let's try to run the code, see if we pass the test case, all right? You see, for the weird tree that we had, right? I told you guys the diameter was 8, so that worked out, right? We got the right result. So let's check if we pass all the test cases, guys. I hope I do. Perfect, guys. We're able to pass all the test cases, guys. I want to thank you guys for taking the time to watch this video. Let me know in the comment section if I was able to explain to you guys, if you guys understood what I was trying to explain. And also, if you guys are new here, make sure to subscribe because I'll do other videos like this. And yeah, guys, I want to thank you guys for watching this video, and I'll see you guys in the next one.